This is a reminder Class Connect sessions are recorded and distributed for learning purposes that are listed here. As always, be respectful, appropriate, and participate. Please don't share personal information during the class for your own security reasons. So I hope again that you had a wonderful weekend. I was happy to hear about some of your plans, what you did for Mother's Day. That's awesome. We aren't going to do a question today though, because as I mentioned, we do have an exam. So I want to make sure we have plenty of time to get through the exam. I do hope you have a wonderful day though after we finish our exam for today. Okay, so let's go ahead and open up our ticket. Links are in the chat box along with today's password. You can see it right next to the word password down there. Green checks if you have it open and ready to go. I've got 12 green checks. Thank you, Amanda, Tony, Bradley, Dolly on top of it. Thank you, Ethan, Israel, Jacob, Jody, Caleb, Kyler. Thank you for your green checks. Awesome. Michelle, Noah, Orlando, Parker, and Shoshana also with it. Looking good. Hi, Arrow. Hi, Ireland. How are we doing today? Looking good. Green checks, everyone. Awesome. I have 18 green checks. Looks like we're able to get it open. That's what I love to see. Perfect. Okay. So here we go. There are only 23 days left of school, so it's going to be ending soon. We are already in week 5 out of 9, so we're about halfway through, which speaking of being halfway through, that means that we have our midterm exam today. All right, so midterm exam, definitely not going to be super bad. I'm going to go over the information that we need for each question, so you will definitely do well as long as you're meeting me halfway and participating today. You'll notice that we are starting Unit 6 then. Remember, Unit 5 was last week when I was out for our testing, while I was proctoring testing. So hopefully you guys got the information you need out of that, because we are going to go ahead and move straight on to Unit 6. Smiley faces, everyone, if that makes sense. Smiley faces, everyone, if that makes sense. Excellent. Awesome. Okay, so we will have a lab on Wednesday, so we'll make sure we get that done. 23 days left of school. All right, so let's go ahead, jump into that. So Unit 5, hopefully, again, last week you should have gone over Unit 5 with those recordings that I gave you. So we talked about the properties of elements, how they're placed on the periodic table, why they're placed there. We talked about metals versus non-metals, and we talked a little bit about compounds. So again, hopefully you watched those 2 recordings for last week and you are all caught up on Unit 5. If not, you still have that opportunity. Just go to your grades tab. Everything you need is in your grades tab. Okay, so our objective for today, again, is the midterm exam, which means we're going to go over all of the 5 units that we have covered so far. So we're going to talk about matter, atoms, elements, molecules, and the scientific method, gas properties and laws, including those relationships between temperature, pressure, and volume. We'll talk about physical versus chemical properties, talk about the phases of matter and how energy is related to those, and talk about the components of atoms and how atomic mass can change. All right, so we've actually learned quite a bit in the 5 weeks that we've been together. So let's go ahead and take a look at this. So what I would like you to do, okay, you are going to actually have 2 things open. So you can have your attendance ticket open and your midterm open. If for some reason you can only have 1 assignment open at a time, I recommend just have your midterm open and then jump back into your attendance ticket at the end of class. Smiley faces if that makes sense. So you can answer number 1 in your attendance ticket right now, save it, and then kind of close that out and go into your midterm instead. So again, the attendance ticket I've already sent in the chat box. Here is your midterm exam. Okay, so go ahead, give me a green check again once you have your midterm exam open. Again, if you can't have more than 1 open at a time. Yeah, absolutely, Israel. If for some reason, again, you want, you can just take pictures instead and then finish it on your own after class. So that's totally an option too, especially since we do go a little bit fast. Okay, so I really recommend take pictures or screenshots with your phone if you would like to. Okay, so the midterm exam is the largest grade in your class up to this point. So it's really important we get this done today. So make sure you prioritize this. You won't get very long to answer, all right? So you'll get about 30 to 60 seconds each slide, depending on how many questions there are per slide. So again, you can either take a picture or you can answer very quickly and then give me a green check. The quarter ends the 2nd Friday of June. So that would be the 14th. June 14th is our last day of the school year, and then you're on summer break. Okay, so here's the deal, everyone. The exam is actually more like an hour long, and we only have 45 minutes together. So I'm going to go over all the hard questions in class. In the easy questions, I have a video for you that you can watch, and you'll get that at the end of class. Smiley faces, everyone, if that makes sense. So we're going to do hard questions together, easy questions. I will give you a video that's going to go over all of those. Okay? This is in Unit 5, but again, the midterm exam is actually going over all of the, oh, sorry, I should say 5C, not 3C. It is going over all of the units 1 through 5, okay? All right, everyone. So that being said, I am going to be asking for lots of green checks today. If I see that you're not answering me and that I'm waiting on you a whole bunch, I will go ahead and put you in the MIA room until you're ready to come back and participate. Usually I don't do that because it's okay usually, but today we need to make sure we're on time, going fast, so make sure you're giving me green checks when I ask you to, okay? This is number 1 in your ticket. Give me a green check when you have it saved. You have 30 seconds. Ready, set, go. Again, this is the largest grade, so fill in the blank with the word largest in your attendance ticket. Get that saved. If you want to close out of it until the end of class, just make sure that it's saved for number 1. Yes, for the attendance ticket, hold on. All right, here's the attendance ticket, Damien, and then again, the rest of class, we are going over the midterm. So here is the midterm. Sorry, let me put a little break. All right, perfect. Looking good. Let's go ahead and keep on moving, everyone. All right, everyone. So again, we're going to be skipping around. I'm skipping some of the easy questions. We're going straight to the hard questions. So we're going to start with numbers 5 and number 6. So on this slide, we have the information that should help us answer both 5 and 6. We are reviewing together, okay? Please don't put any answers in the chat box. All of this is your own exam. You are working on your own individually. Okay, so remember we talked about the difference between physical versus chemical properties. And remember we said physical properties do not change the chemical makeup of matter. They don't change the actual chemicals. So things like the smell, freezing things, boiling things, melting things, changing their viscosity, changing their density. These things don't actually change they don't change the actual identity or the actual molecule. So for example, frozen water is still H2O, liquid water is still H2O, and gaseous water, steam, is still H2O. So the actual atoms and chemicals aren't changing. Smiley faces if that makes sense. Okay, so physical properties, if you change them, you're not actually changing the identity. Chemical properties, on the other hand, do change the chemical identity, okay? So for example, sometimes things will react with water, or if you burn them, that changes the actual molecules and atoms and how they're arranged. So for example, zinc, when added to hydrochloric acid, will break chemical bonds, releasing energy and producing hydrogen gas, which is a new and different chemical substance, okay? So remember, the amount of matter and energy doesn't change, just the location and type, but again, we're rearranging atoms and we're creating different substances. We're changing identities, okay? So this should help us answer number 5. So number 5, take a look over here, and then number 6, we can take a look over here as well. So go ahead, give me a green check when you have both of these saved. I'm going to go ahead and give you 30 seconds. Again, if you need to, take a picture and then give me a green check, but I need green checks from everyone. If I don't see your green check, you will go to the MIA room. Thank you. Go, go, go. Okay, I need a green check from Andres, Ashton, Chanel, Donnie, Dorian, Dree, Edwin, Elias, Ethan, Misael, and Yolese. Green checks, please. Moving on in 5 seconds. And here we go. All right, everyone. So we're going to go ahead. Again, we're skipping around a little, so we're going to be answering questions 10 and 12. So scroll down, take a look at questions 10 and 12. Make sure 5 and 6 are saved. Okay, so remember, we just talked about this, this idea of conservation of matter and energy, which means that matter and energy within our universe can't just magically appear or disappear. Instead, no matter what, the total amount of matter and energy in our entire universe is constant. Okay, so if matter changes form or energy changes form, no matter what, it's not going to be made. We don't magically create new stuff. We don't magically delete stuff. We don't magically destroy stuff. It's always in total the exact same. Smiley faces, everyone, if that makes sense. Smiley faces, if that makes sense. Okay, so whether we're talking about matter or energy, they're both conserved. All right, never making new stuff. Okay, so cannot be created, cannot be destroyed. It can just change forms. Okay, now this also goes with this idea of how we talked about how molecules and gases can collide with each other. So when molecules or atoms and gases collide with each other, again, they're not gaining or losing energy in total. Instead, they're just transferring it from one atom to another atom, or one molecule to another molecule, exactly like billiard balls, right? So one's moving, it hits it, and then the other one begins moving as well. So again, this still shows that energy is conserved. All right, so question number 10, right, we should be able to answer here. And question number 12, this should help you answer this here. Go ahead and give me a green check when you have both of these saved. We have 30 seconds. Ready, set, go. Take a picture if you need to. Okay, need a few more green checks. Tony, Ashton, Bradley, Chanel, Donnie, Dorian, Dree, Edwin, Elias, Ethan, Ireland, Israel, Caleb, Cash, Kyler, Letty, Matt, Misael, TJ, and Yolese. Again, if you need to, take a picture, but still give me a green check. Otherwise, I will begin moving people to the MIA room in a couple questions. So I do need your attention. I do need your green checks. Let's go, let's go. All right, we're moving on. Okay, so let's go back again. We're skipping around. So we're going back to questions 8, 9, and then we'll go back down to question number 13. So this is all about this idea of kind of states of matter, how they can change, and the heat that's involved in changing them. Okay, so the properties of solids, liquids, and gases depend on how their atoms or molecules are moving. Remember, the molecules themselves don't change, right? Whether we're a solid water, liquid water, or gaseous water, it's all still the same molecules. It's all still H2O. The only thing that's changing is how they're actually interacting with the other molecules. So for example, solids, all those H2O molecules are just kind of vibrating in place in their rigid structure, right? So they have a definite shape and a definite volume that does not change. Liquids, on the other hand, same H2O molecules, but now they're free to move and flow past each other. They still stay close to each other, though. So that means that they don't have a specific shape, right? Because they can flow and move around, but they do have a specific volume because, remember, 1 cup of liquid water will still be 1 cup of liquid water, even if you pour it into another container. And then gases, again, still those same H2O molecules, but now they're so chaotic that they can actually pull apart completely and move around on their own, which means they don't have a definite volume. They can spread out and get larger, and they don't have a definite shape, right? They can move around a whole bunch. They're very chaotic. Smiley faces, everyone, if this makes sense. Solid, liquids, gases. Again, all H2O in my example, but how they move changes. Okay. Now, that being said, in order to go from one of those states, solid, liquid, gas, to another state, you either need to absorb energy or release energy. Or this type of energy we're talking about is thermal energy or heat energy. Okay, so thermal energy, heat energy, we can also call that molecular movement. Faster molecules are hotter, slower molecules are what we consider to be colder. Okay, so that being said, that should make sense, right? If we want to go from ice to water, getting warmer, we have to add thermal energy. We have to get hotter. They have to move faster. Same thing if we want to get a gas. They need to begin moving even faster and faster. So we can see like melting here, evaporation. Both of these are getting faster, adding energy. Okay. On the other hand, if you want to remove thermal energy, remove motion and get colder, that's like going from gas to water. That's condensation, or from going from liquid water to ice, that would be freezing. Okay. So we can see all of those examples here. Okay. So number 8, let's see here, is talking about these right here. Number 9 is talking about what you see in this diagram here. And then number 13 is talking about this idea of thermal energy right here. Okay, so go ahead and answer questions number 8, 9, and 13. I'm going to give you a little extra time. You have 1 minute. Ready, set, go. All right, waiting on a few more green checks. Andres, Bradley, Bree, Dorian, Dree, Edwin, Elias, Jasmine, Kyler, Letty, Misael. Green checks, please. Again, at this point, I'm going to begin moving people to the MIA room so I don't have to keep on saying the same names over and over again. So please make sure I'm getting your green checks. Kyler, Letty, Elias. Thank you, Dorian, Donnie, Dree, Edwin. Green checks, Bree. All right, everyone, give me a moment to move a couple people around. Just want to make sure we're not wasting everybody's time. All right, looking good, everyone. All right, sorry, everyone, 1 second. All right, perfect. Okay, let's go ahead and keep on moving. All right, everyone, so we're going to go ahead and talk about questions 11, 15, and 14 now. Hi, Efren, good to see you. Open up your midterm exam. We are working on that currently. Same with you, Andrea. I know you just joined us, so go ahead and get that midterm exam open. So we're going to questions 11, then skipping to 15 and 14. So this is all about gases. All right, so remember, we just talked about this. Gas atoms or molecules, they have very high thermal energy, heat energy, and so because they have so much energy, they can move randomly, they can spread out, it's very chaotic. They will collide with each other and with their container walls, which creates pressure, right? All of those collisions equal pressure. So remember, we talked about this a whole bunch. Collisions equals pressure. No worries. I missed you too, Efren. I'm so glad you were able to make it. Cool. So this is our kinetic theory of matter, which says that gas atoms and molecules are very small energetic molecules that are bouncing into each other, into their container wall. And so gases at high pressure have more collisions, right? More collisions, more pressure. Low pressure means less collisions, okay? So they're the same thing. More collisions, more pressure. Less collisions, less pressure. Smiley faces, everyone, if we understand that. Collisions and pressure are the same thing when we're talking about gas molecules. Awesome. Now, gas molecules have to be stored. Sorry, 1 second, everyone. Here we go. Gas molecules have to be stored in a container, which can be difficult, right? Because if you don't store them in a container, they'll just spread out forever, and then you no longer have that gas, right? It's like when you let helium out of a balloon, it spreads out immediately into the entire room, okay? So in order to store it in a container, you have to compress it with a pump, because remember, gases will take up a lot of space. So by compressing it and kind of stuffing it into that container, Efren, we're going over all the information together, but we're not answering them together. So you need to answer them on your own, but you'll see here that I'm going over all the info related to each question. Great question. Yeah. And this results in very high pressure. That's why compression has the word pressure in it, right? Compressed, high pressure. All right, so that's all about compression. Good. Now, the last thing we talked about that's related to one of your questions is this idea of air pressure and altitude. Remember that the higher up you go, is it easier or harder to breathe? Tell me in the chat box. The higher up we go in the mountains, is it easier or harder to breathe? Yes, it's much, much harder to breathe, right? It's harder to exercise, harder to get your breath. And the reason is because there's just less oxygen up there. Remember, air molecules act like a dog pile where all of the ones at the bottom are feeling a lot of pressure and there's a lot of them collecting at the bottom. Whereas at the top of the dog pile, there's less pressure on them, less molecules. And so it's harder to breathe at the top when you get higher and up higher on the mountains, okay? Smiley faces if that makes sense. The higher up you are, the less air pressure there is, the harder it is to breathe because there's less molecules. Awesome. Okay, so question number 11, all right, question number 11 is asking about this right here. Question number 15, let's see here, is talking about the kinetic theory of matter. Awesome, awesome, awesome. Sorry guys, 1 second. And then question number 14 is asking about this idea of air pressure. All right, so go ahead, give me a green check when you have all of those saved. You have 1 minute. Green checks, everyone. If you need to, you can take a picture and then give me a green check. Go, go, go. It would be hard for me to say, Efren, because we're kind of jumping around. So we've gone over some of them from the beginning, from like 5 and 6 and 8. And yeah, I don't remember. You'll have to watch the recording for anything that you miss, okay? Cool. All right, everyone. So let's take a look at this. I just need a couple more green checks. Chanel, Donnie, Cash Letty, Rozzy, TJ. Make sure I'm getting those green checks. Otherwise, again, if I don't hear from you in a little bit, I will move you to the MIA room. Thank you. All right, let's keep on working. Okay, so remember we talked about a lot of the physical properties of gases, right? And there were 3 of them that we focused on. So pressure, right, which means collisions, the amount of force kind of pushing out on the container. Volume, which is the amount of space that a gas will take up, which in general is the volume of the container because they'll try to spread out to fill their entire container. and temperature, which is the average heat or kinetic energy of molecules. Remember, faster molecules means it gets hotter. Slower molecules means it gets colder. But the thing that we learned in our gas unit was that all of these things are related to each other, and if you change one, it will actually affect the other properties as well. Okay? So, for example, right, so we talked about this idea of the kinetic theory of matter, which says that pressure is due to the collisions as molecules bump against their container wall. Now, that being said, for example, if a container is expandable like a balloon, all right, then as we increase pressure, okay, sorry, hold on. If a container increasing pressure, sorry, this should say decreases. This is a typo. As we increase the pressure on that, it will actually decrease the volume of the container. All right, so for example, you can see that over here, right? That as we, sorry, hold on. This is backwards, hold on. Yeah, okay. So sorry, this is number 16 right here, okay? So sorry, make sure you guys note this, that this is an error here, okay? So if you increase the amount of pressure on a container, okay, like for example, a water bottle, how many of you guys have ever done that twisty thing with the water bottle? You guys know what I'm talking about? Where you try to twist the water bottle until the cap falls off. Yeah, so what you're essentially doing is you're trying to increase the pressure or the force on that bottle, and so it decreases the volume of the container, but remember that as you increase pressure, eventually it might actually explode and the pop cap comes off. Smiley faces for everyone if that makes sense, right? So if you're decreasing volume, the pressure increases, or the reverse. If you are increasing pressure, then the volume will decrease. Yeah, Efren, if you like light a match and then put the match out and then stick it inside of the bottle with the smoke, then you can actually create clouds whenever you squeeze it. It's a really cool experiment. You guys should definitely look that up if you haven't. Maybe I'll do that for my next class. That's a good one to remember. All right, now on the other hand, yeah, exactly, Efren. On the other hand, if you increase the temperature of a gas, right, then those molecules get more kinetic energy, they move faster and faster, and so with a stretchy container, they're going to begin to expand that stretchy container to kind of compensate for all that extra energy. Smiley faces, everyone, if you understand. Smiley faces, if you understand. Increasing temperature will increase pressure or volume depending on if it's stretchy or not stretchy. Okay, so for example, if it's stretchy, like a balloon, then it will increase volume. All right, looking good. Sorry, guys, I need to remember to edit this slide because there's a couple typos on it. Awesome. All right, this is number 17 and 16. Go ahead and give me a green check when you have it saved. You have 30 seconds. Ready, set, go. Looking good. Waiting on a few more green checks. Dree, Efren, Ethan, Cash, Letty, Rozzy, green checks, please. Yes, go for it, Ireland. Thank you for letting me know. Perfect. All right, let's keep on moving, everyone. Okay, question number 18 is talking about buoyancy. So remember we saw this great video of, sorry, one second. All right, we saw this great video of that guy with the empty scuba tank and the full scuba tank, right? And the empty one was able to actually float in the pool, whereas when he dropped in the full scuba tank, it actually dropped to the bottom. Because remember, gases, air, actually do have some mass to them. Smiley faces, everyone, if that makes sense. Remember, gases do in fact have some mass, some weight to them. So if you fill something up and compress a gas, it will actually begin to sink, all right? So changing the gas's volume changes its buoyancy, how well it floats, right? So if we compress a gas, which increases its density, it's going to begin to sink because we have more mass for that volume, making it less buoyant, more likely to sink, right? So heavier gas in that gas tank. Okay. On the other hand, when we decompress a gas, that actually decreases its density, right? So as the scuba diver uses up all that oxygen, all right, it's going to begin floating, right? Because he's using up the oxygen, it's emptying the tank, and now there's less mass in that tank, and so it's going to begin to float more. Okay. So this is number 18. In your ticket, go ahead, give me a green check when you have it saved. Read that carefully. You have 30 seconds. Green checks, everyone. All right, looking good. Efren, I can't explicitly give you the answer, but right, so compressing it makes it more dense, making it sink. Decompressing it makes it less dense, allowing it to float. All right, looking good. Waiting on a few more green checks. Damien, Dree, Ethan, Israel, Jasmine, Caleb, Cash, Misael, Rozzy, green checks. All right, moving on in 5 seconds. Awesome. All right, everyone, let's keep on going. All right, so again, we are skipping around. All of those easy questions will be in a recording that I'll be giving to you in a moment. So we're just going over the hard ones together. So right now we're skipping down to questions 24, 25, and 26. So scroll down to the end of your exam, last 3 questions. Again, all the other ones I will be giving you a recording in a moment. Okay, so these questions are all about the nucleons, which means the particles that make up the atomic nucleus. And that means the protons and neutrons are the nucleons, right? So anything in the nucleus, those are called nucleons. So that means protons and neutrons. Smiley faces if that makes sense. Okay, so protons and neutrons are in the atomic nucleus. Therefore, we call them nucleons. Okay? Now remember, protons are all positive, right? Like pros versus cons, pros are the good ones. So protons are all positive. But remember, when you have a bunch of particles with the same or like charges, remember that they actually want to repel each other. So we would imagine that protons would want to actually repel each other. But if they were to repel each other, our entire nucleus would fall apart and we would get lots and lots of explosions, okay? So obviously our atomic nucleus is not falling apart, which means that there is something that is helping those protons stay next to each other. So the things that are helping them are neutrons. Remember, neutrons are neutrally charged, and so they help keep protons far enough apart from each other that they're not going to repel each other. Okay, so that's our basic understanding of the nucleus. But if we were to actually zoom in even further, remember protons and neutrons are actually made up of even smaller particles called quarks. All right, so these are fundamental particles of protons and neutrons, and it's actually the attractions between these ones that are actually really keeping the nucleus together using what's called the strong nuclear force. So remember, protons are made up of 2 up quarks and 1 down quark. Neutrons are made up of 1 up quark and 2 down quarks, and these are oppositely charged. So right, the up quark in one proton might be attracted to the down quark in a neutron, right? This is kind of an oversimplification, but this is what's helping keep our atomic nucleus together, are these interactions between these quarks within our protons and neutrons. Smiley faces if that's beginning to make sense. Smiley face if that's beginning to make sense. All right, looking good. So question number 25 is asking about nucleons. Question number 24 is asking about protons and neutrons. And question number 26 is asking about the nucleus. All right, go ahead, answer all of these. You have 1 minute. Green checks when you have it saved. Ready, set, go. All right, just waiting on a few more green checks. Andrea, Chanel, Damien, Dolly, Dorian, Dree, Efren, Jacob, Jackie. Hello students, this is the easy questions for the midterm exam, the 5C midterm exam. So let's go ahead and start going over these questions. Again, the hard questions have already been answered during the live class or during the recording from the live class. So reviewing matter, atoms, elements, and molecules. Remember, a matter is anything that has mass. All matter is made up of these tiny building blocks called atoms. So atoms are these really small building blocks. You can't go any smaller than an atom and still keep its identity, right? Now, if you take many of the same type of atoms, so for example, many gold atoms, put them together, that's what's called an element. An element is a pure substance that you cannot separate physically or chemically because it's just made up of one type of atom, right? You can't break it down into anything simpler. Okay, so at this point you should be able to answer question number 1, talking about what matter is, question number 3, talking about a substance that cannot be separated physically or chemically, and question number 4, talking about what it means if something can't be separated physically. All right, so go ahead, answers 1, 3, 4, and then go ahead and continue playing the video. Okay, so the next question is talking about the differences between chemical and physical changes, specifically talking about physical changes. So physical changes mean that matter changes without actually creating new substances. So the actual chemicals all stay the same. It's just that physically it might be changing a little bit. So for example, if you add energy to crush a pile of rocks, the powdered rock is still made of rock. So even though its shape and its texture are different, the actual chemicals in the rock, the arrangement of atoms are exactly the same. So this has to do with, for example, phase changes, which is going from solid, liquid to gas. With water, liquid water, ice water like icebergs, and gaseous water like clouds or steam. These may all look different, but because they're all made of the same water, the same H2O, these are actually just physical changes. So that should help you answer question number 7, talking about the difference between physical and chemical changes. Go ahead, pause the video, answer this question, and then continue playing. The next question is talking about matter and atoms. So we're skipping down to question 19. Again, all of those hard questions we've already answered in class, so we are skipping around here. So again, matter, anything made up of mass, made up of those building blocks called atoms. Elements are made up of the same type of atom. Now specifically, when we talk about the atom is the smallest unit that still keeps its identity, right? So we talked about earlier, if we tried to split a gold atom into something smaller, it would no longer be gold, and therefore it is not the building block of matter, because anything smaller loses its identity. Okay, so the atom is the smallest thing that does keep its identity. Please answer question number 19, pause the video, and then continue playing when you are ready. Question number 23 is talking about the atomic models and science. Oops, sorry, let me go back up to that. All right, so skipping down to question number 23. So there are a lot of different models that we learned about. The atomic models are important because they allow us to describe the behavior of atoms. And the reason that we need models is because atoms are too tiny, so we can't actually take a photo of them because we've never been able to actually see them. So it's important to have models so that we can kind of understand what an atom might actually look like. Remember, we started out with this atom that was just a solid sphere. That was Dalton's model. From there, we decided that the model was a giant sphere of positive charge with little raisins or pieces of negative electrons studded throughout it. That was the Thomson model, or the plum pudding, or the raisin bread model. Rutherford consolidated all of the mass, which was the protons and neutrons, into the very center of the atom, which he was the one that pioneered the idea of the nucleus, this very dense part of our atom. And then the Bohr model put the electrons in specific areas around the nucleus. So they exist at certain energy levels around the nucleus, which we call orbits or shells. And then the most recent model is a little bit, it looks similar to Bohr's, but in reality, electrons are impossible to know where they are at any given time. So all we can show is their most likely location. So based on the probability model of where they are most likely, we see this kind of fuzzy cloud around our nucleus, and that is what is called the electron cloud model. All right, so at this point you should be able to answer question number 23, talking about where those electrons have been. Go ahead and pause the video, answer 23, and then continue going. All right, so the next 3 questions we're answering 20, 21, and 2, so you will be moving around in the exam right now, is all about the atom. So atoms have 3 parts. Remember, they have positive protons, which are in charge of the atom's identity. And if you see on the periodic table the number on top of each of those squares, that's called the atomic number. The atomic number gives you the number of protons, or the atom's identity. So for example, oxygen always has an atomic number of 8 because it always has 8 protons. Neutrons are neutral, and their purpose is to prevent protons from repelling inside of our nucleus, because remember, our nucleus, if it's only made up of positive protons, it will split apart from itself. So the neutrons are there to act as a buffer, neutrally charged, keeping those protons from repelling. Electrons are negatively charged, and remember, they're on the outside of our atom, and because they're on the outside, just like you would hold hands with somebody and not shoulders with somebody because your hands are further out from your body, the electrons are therefore the furthest out particles, and so they can be involved in bonding or joining hands with other atoms. Now, in terms of size, remember, all of our mass is concentrated in our nucleus, so only protons and neutrons really have mass. They each weigh 1 AMU. So, for example, you see 3 protons, 4 neutrons here. That would be a mass of 7 AMUs in total. And electrons are so very tiny that we basically don't count them as having mass. So they have negligible mass, meaning almost 0 AMUs. We don't really count it when we talk about atomic mass. You can see that right here. Again, atomic mass is going to be the sum of the proton mass and neutron mass, again, only found in the nucleus. Protons, neutrons, again, they're in the nucleus. Most of the atom is actually empty space. So the nucleus is this very tiny, dense part inside of the center of the atom. But the rest of the atom is actually mostly empty space with these very, very extremely small electrons just kind of orbiting around that nucleus far out of the atom. And again, most of the atom is actually empty space. So at this point, you should be able to answer question number 20, which is talking about which particle has a negative charge. Number 21, which is talking about what atomic mass is. And question number 2, which is asking about the statement that best describes electrons. Go ahead, pause the video, answer those 3 questions, and then let's continue going. Actually, okay, so here we have the very last question that we will be going over, the very last easy question. This is question number 22. So remember that protons are in charge of identity. So if you change the number of protons, you do in fact change the element completely. It's a completely different type of element, completely different identity. So for example, you can see here hydrogen always has 1 proton. Helium always has 2 protons, and that proton makes a very big difference in terms of identity, right? We talked about how both of these could be used to fill up balloons, but we actually don't use hydrogen because hydrogen is actually flammable and can explode if you if it gets lit on fire, right? Which was a disaster that we talked about in history within our class. Helium, on the other hand, is non-flammable. Remember that extra proton makes a big difference. It's an inert gas, and as a result, it is good for blowing up children's balloons, unlike hydrogen. Now, on the other hand, you can change the amount of neutrons, and this won't change the identity of the element, right? So if we have a hydrogen atom and we start adding a bunch of neutrons to it, it will still be hydrogen because neutrons have no effect on identity. The only thing that they do change is the atomic mass, because remember, neutrons do have mass. They each weigh 1 AMU, 1 atomic mass unit. Now, this is what's called an isotope. So an isotope is a variation of an element based on different atomic masses because of their number of neutrons. So for example, you can see here that all of these 3 atoms, these 3 elements, are all hydrogen, H for hydrogen, because they all have 1 proton, right? Their atomic number, their number of protons is all 1. And that means no matter what, these will always be hydrogen. But their atomic mass is in fact changing because you can see we're adding protons. This one has we're adding neutrons. This one has 0 neutrons, so 0 plus 1 proton equals 1 atomic mass unit. Over here we've got 1 neutron. 1 plus 1 gives us 2 atomic mass units. And over here we've got 2 neutrons. 2 neutrons plus 1 proton gives us an atomic mass of 3. So again, they're all technically hydrogen because they all have 1 proton, their atomic number is 1, but again, their atomic mass is changing, and therefore these are all what we call isotopes of hydrogen, different types of hydrogens based on their masses. That's all we have. At this point, you should have answered every single question in the entire exam, jumping around. We did the hard questions in class, the easy questions in this recording. Thanks so much, and I will see you all later. Okay, so here was our objective, right? Talking about all of the different things that we have talked about in class. So here's what's going to happen now. I do have a recording for you to go over the easy questions for the midterm exam. Remember, this recording here is going to help you answer all of the remaining questions. Yes, I will also include the easy questions in the 5C recording. Smiley faces, everyone, if that makes sense. I always embed it in addition to our class recording. That way you'll have it either way. But here's the link right here, just in case you want to get started on it right now and you don't want to wait for it to upload. All right, so go ahead, open that up, give me a green check if you've got that link, got it saved. Efren, it will be in the recording. All right, so I'd rather have you go through the recording because I don't want you just to look at the slides. I want you to actually hear the information that we reviewed. Okay, awesome. Yeah, just make sure everything's saved, and then that recording should be up in a little bit, okay? All right, awesome, everyone. Looking good, looking good. All right, here we go. Again, green checks if we have the YouTube video for the easy questions. Since we skipped some of them, they will all be in that YouTube recording. Excellent, looking good, everyone. All right, here we go. Here is the last word. Thank you so much, everyone, for being here today. We're ending a little bit early so that you can use this time to finish up your midterm exam. Thanks so much, everyone. See you all later. I'm going to put the links up on the whiteboard.